Hello, students and seekers of general truths. Let us evaluate this important limit here. The limit as theta goes to 0 of sine of theta over theta. Okay. So one thing I want to point out here is that direct substitution will not work. We cannot simply just plug 0 in here for our answer. So what we have to do to really approach this problem is use the information that we had from the previous video for the previous question. Okay, and this is what I call sneaking up on the solution. So we're going to try to sneak our way onto the solution. And how this came about, well, I'm not really sure. I think it was Newton or Leibniz who came up with these results to begin with. But it's part of their genius that they're able to figure this out. I'm really just showing you here is the result of their work. So let's review what we have up here. We have 3 areas: the blue area, the purple area, and the green area. And I hope you can see here that the blue area is going to be the smallest of the 3, and then the purple, the sector area, is going to be the second smallest, and then the green area here is going to be the largest. So I'm going to write that out here in an inequality. So the blue area from what we had above was sine of theta over 2 is less than or equal to. The blue area from what we had above was just theta over 2. And then over here we had tangent of theta over 2. Okay. And I'm going to explain, of course there's inequality, but I'm going to explain the equal to in just a minute here. So if we look at this picture here, you see this is just a more dynamic version of what I had earlier, right? The blue area is inside of the brown or the purple area. Maybe I should change this color here to purple. Let's see if I can do that. It's inside the purple area, which is inside of the green area. And as I move this angle, as I move theta, the 3 areas get closer and closer together. So at some point, like down here, they're totally equal, right? But generally speaking, they follow an equality or an inequality. So it's an inequality, but it's not strict because they could be equal to each other in some rare circumstances. Okay. And now we're going to sort of mess around with this inequality a little bit and sneak up on the correct answer. So the first thing we can see is that we can get rid of all of the 1/2 since they happen to have 1/2 in there. So sine of theta is less than or equal to theta, which is less than or equal to tangent of theta. Okay, given the picture that we had above, right? So this is building up on the picture that we had above. Okay, and then I am going to rewrite a few things. So let's see, I'm going to still leave sine of theta here. We'll have theta here in the middle, and then I'm going to rewrite tangent. Remember that tangent is sine over cosine, okay, from what we know about trigonometry. Tangent is the same thing as sine over cosine. In the next step, I am going to divide everything by sine. So I'm going to divide next by sine. Okay. So if I divide everything by sine, let's see what I get. Well, sine divided by sine is just 1. Theta divided by sine is just theta over sine. And then theta over cosine divided by sine, I'm just going to get 1 over cosine of theta. Okay. And now you can see that our sneaking process is working out pretty well. We started out with something that's unrelated, and we end up with an expression that's almost like the one that we had. So now what we can do is take the reciprocal. So all we have to do now is take the reciprocal. Well, the reciprocal of 1 is just 1. The reciprocal of theta over sine is sine over theta. The reciprocal of 1 over cosine is just cosine. And because we're taking the reciprocal, we have to also flip these inequality symbols. Okay? So on the side note here, if you have a fraction like 1/2, is definitely greater than, say, 1/3. Right? But if I take the reciprocal, 2, this would be 3, then I have to flip the sign. Okay? So that's the rationale for flipping the sign. And now you see that we are almost done. We are ready to complete this question by taking the limit. Okay, so let's take the limit of all three of these. So what is the limit, as theta approaches 0 of the left part? What is the limit as theta approaches 0 of the middle part? And what is the limit as theta approaches 0 of the right part? Okay. Well, there's not even a theta in here, so the limit of a constant is just that. It's constant. It's just 1. Okay. The limit in the middle here, we don't know, so we'll just write it down again. Limit as theta approaches 0 of sine theta over 0 is less than or equal to the limit of cosine theta as theta approaches 0. Well, we could use direct substitution. Make a side note here. Cosine of 0 is just equal to 1. Right? On the unit circle, cosine of 0 is equal to 1. So now we've arrived at our result, which says that this limit that we're looking for is some number between 1 and 1. Okay, so this is the beauty of this inequality. It says the limit that we're looking for is between two numbers, but they're the same number. So the only conclusion here that we can arrive at is that the limit of theta approaching 0 of sine theta over theta must be exactly 1. Okay? Because from our inequality, it's a number between 1 and 1. So it must be equal to exactly 1. All right, so we'll end it there. And again, this is the building block, and you'll see in the next video, in the next several, why this limit here is so important. I named this an important trigonometric ratio and limit. And I promise you it is important for some of the derivatives that we will work on. As always, thank you for watching. Keep working hard, and have a wonderful day.